Good morning, everybody. Thank you for coming to this session on managing and monitoring clusters. My name is Luca, and I work for InterSystems as a product manager in the big data project. And so just to set the context, is that of a big data lake. In other words, we're going to have lots of nodes out there running. We're going to have lots of compute resources at our disposal. We're going to have lots of storage at our disposal, and yet, exactly because we're going to have lots of these things, we need to know exactly how everything is performing. So let's go into this presentation. Remember that the aim here is to be able to perform monitoring for a cloud-native architecture. So what does monitoring mean? Well, people think, oh, okay, so they got this image of the dashboard. Great, okay, that's monitoring too. It's, oh, I'm doing S.A.M. I've got a process that does monitoring, that's something. And so it's a term that can be misused. So really, in summary, it's just the awareness of how my system is doing out there. Okay, and we can do monitoring in two major ways: a proactive way and a reactive way. And really, I summarize in 3 points what in my opinion, monitor really is. So of course, the first one is threat detection. So what kind of threats do you have? The first one is obviously performance, and as you know, in the system, we're quite fanatical about performance. So we really want to know how's my system as a whole, and I might have 1,000 nodes out there performing. And of course, if performance degrades so much that it becomes unavailable, or there's a crash, or other problem that that affects the high availability of my system, then I want to know straight away. There's also a second point, in my opinion, that's very, very important, which is the forecasting, I call it. And it's about understanding a baseline. So when I say, oh, my system is performing good, quote unquote, what does that mean? Is it just running 40% CPU? Okay. What about if it's running a 75% CPU? Is that normal for your system? Well, actually, I would argue that it could push up to 90, 95%, and it could still be pretty normal. Because if I just spend $5,000 on a CPU, I want to make sure that that CPU do some work for me, so that my money is well spent. So, but the point is, we're not able to understand that unless we have a baseline on which to base our opinion on that. And of course, if I'm doing forecast, if I understand what a baseline is, if typically I have a 50%, for example, my storage free, and I monitor what's happening there, then I'm able to actually do predictions, so that I can better have an understanding for my capacity and how much it's going to last. And the last point is automation. I think we're going to. It's not just going to be the pager that gets a trigger that does something that tells the system administrator to get up in the middle of the night, but it's really looking at autonomic computing, or computers that can take care of themselves, so they can self-heal and self-optimize. But anyway, even if they do that, I would like to know, for example. So technically, when I speak to technical people, they say, yeah, we've got S.A.M, or we got Nagios, or we've got these tools, they're all great. That's what you're using here, but how do you do it? And the point of this slide really is, have you really thought about all the elements of a monitoring system? And as our target here is the cloud, as our target here is thinking about many system, a cloud-native architecture, maybe with microservices, maybe with Docker containers running. If you came to my previous presentation, you would have heard these terms. Then what does it mean, monitoring there? All right. So the point here is saying, and this comes from experience. You typically go on site, or you help somebody to deliver something. So we install the application, we install the couple of corollary system, like web services and some analytics system, and then you say, oh yeah, it would be nice to have a little bit of monitoring. So, oh, let's just spin up a little VM, little Windows VM. We put Nagios in there. We got a couple of dashboard, and we just do a little bit of pinging and make sure that the load balancer and database answers within a certain amount of time. that's not really monitoring. It's a good start, okay, and we've probably all been there, and that's okay. But in general, I would say the whole point of this slide is we need to really step back a little bit and understand that there's an architecture that needs to be put in place. And in my opinion, especially when we look at big data, cloud-native architecture, where we're going to have thousands of nodes out there, we should take the same care of thinking about it as the care that we look at that we take for the application. Okay. So, for example, if I've got 1,000 nodes, I want to monitor them. What happens if my monitoring system, a little VM, Windows VM, just dies? So I want to make sure that at least I've got some HA capability there, for example. Why? Well, because I've got a cloud of resources out there that I need to monitor. Okay. So what do we cover for the monitoring system? Well, there are three main areas. So it goes from the resources from low level, from networking and hardware that we know, CPU, memory, etc. And we go up to the software layer. So we go the OS, of course, and then my cache database, other software, my JVM that I'm spinning up, my Python, my Golang libraries, etc. But the last one was very important, right at the top. The user experience. Do we know, for example, what's the average latency that my users of my application are experiencing when they connect to my page? And all these things are very important, because then, if somebody calls me and says we have a performance problem, well, what does that mean? Is it just the user seeing a delay? Is it maybe just some latency there is because it goes through standard internet channels, or do I really have some problem in the lower layers? But these are the summary of the three main layers of monitoring that we would like to really take care of. So the scenario is that it is late Friday afternoon, and we're all getting ready to go home. And if you're in London, you probably go out with your mate to a pub, and somebody calls up and says there's a performance problem. Okay. So what do we do? So the scenario is that we're looking at the standard application that we've been building for the last 50 years. So it's just a big monolith, and in a way, that's pretty easy. Why? Well, because I have, as far as the monolith is concerned, my application running one system, one single point of failure. So I've got a system log, I've got a cache,cconsole.log, maybe a couple of other logs from Apache or Nginx. But the point is I can SSH in there and grab something and find out from the logs what's going on. So single point of failure, it's quite easy. You only have an SPI, one single point of investigation. But as I said at the beginning, we have a data lake, we have cloud that we're looking at. So things are a little complex, a little bit more complex. So let's go through these scenarios. So the first scenario is I've got a single service and a single server, and it's exactly the user case of the Friday afternoon. But still, even for a monolith, typical 50 years old application, what is my baseline, and how do I start performing intelligent monitoring over it? And yes, I can use SSH, I can do grep, a couple of greps and a couple of logs file, maybe I can start figuring out what's going on. And as I say, it's a single point of investigation. Generally, it's pretty easy. And maybe that's why generally we see that there is not much monitoring going on in many of the applications that our partners have. But we would like to encourage a lot more of that, because it's very important, and we can catch trends, create better intelligence on how the application performs, and more to the point, understand the trending of the application, therefore be prepared for the future. The second scenario then is that I've got a single service still. So let's take like my app as a web service on multiple servers. So things start getting a little bit more complex. Also, what I have here, because I've got the same service multiplied over, I need to put a load balancer. So the first thing that I notice, I'm doing the same exact monitoring here. I've got the same type of logs, but everything it's already doubled up. And yes, as a single SSH, maybe it's not that great, but I could use an SSH multiplexer. Yeah, you can do that. It's probably just okay for three servers. But I have, an aggregator here, an extra utility, that load balancer, that needs to be taken care of in terms of, how is that doing? Is it really performing? And really, if I'm looking at an enterprise level architecture, well, that load balancer cannot be alone. It has to offer HA too, high availability. So I need at least 2 load balancers, right? So all of a sudden, we see that just by spreading across, horizontally growing, and our architecture, we start getting any problems. So how do we monitor this? Let's go to the next level. So maybe we talk about a really more decoupled services, maybe microservices. You're already approaching modern cloud native architecture. So we have our web services that was in the previous picture, but also have a login service and a few other obviously application specific services at the bottom. And all of them have a series of servers. So how do you do monitoring with this? Okay, so if I just want to, just a simple operation, grabbing some information through the logs, even SSH multiplex is just not going to be good enough. You're gonna waste a lot of your time. So the answer for this is really we need to operate that last line on the slide, starting collecting and aggregating information. And that's really the only way that we can start tackling this type of issues. So let's have a look at logs, for example. How do you operate with logs? Typically, you have a collection aggregator, a log collection aggregator that reads the console.log, the system log, your Apache log. And what it does, it just pushes that information. So it collects the information, aggregates it, and throw it over to a system that's dedicated. So you could have a time series type of database and a viewer to view the information. And of course, that viewer then collects information from other systems, from other services. Okay. So that was for logs. But of course, we want to have, as we said, the 3 main layers. We want to have, system metrics, hardware metrics, but also the top layer, the software and the customer experience type of metrics. So for the resources, well, there's all standard stuff that we know: CPU, memory, IOPS, the network level. But all of that, again, the point is we need to collect this information to understand, to be able to view it, maybe to graph it in a different way, maybe to search as something happened, as that Friday afternoon call arrives, versus trying to pinpoint, figure out where the node is as a problem. So you have a processor like collectd and sysdig that allows you to do this job, and then basically they just push this information off to tools like Graphite that allows you to graph information so you can easily understand it. As far as the software and customer application software and customer experience is concerned, we need to really try to understand, the critical points. So the example before was about the latency of the application. It could be, anything else that we care about, like some of the important transactions that take place within the application. And of course, within all this, talking about architecture in general of monitoring, how about synthetic monitoring? So creating events which are, built on purpose to test the system. So to this point, for example, Netflix has what they call a chaos monkey. Chaos monkey wakes up every so often and really goes and kills services, because out there in the cloud, when you have thousands of instances, you don't know, but things are going to happen that are bad, and they will happen. It's only a matter of when, not if. And so if you build that type of synthetic approach to testing, and you actually Netflix does it on its live system, its production system. That's pretty cool, because then they know that they can really sustain some events which are which shouldn't happen, and they proactively do that. So what type of architecture model do we have? Well, we have the old type model, the Nagios one that says, okay, I'm going to ping some service, let's see if it answers, and what happens if it doesn't answer within 2 seconds? What are you going to do? Is the system really down? Do you have any intelligence? What's really happening? And what's behind that system that you're pinging anyway? Do you just have a, an Apache web server? Do you have a database? What does that mean? Is it just slow? Is anything else happening? So this, in my opinion, is very much the type of solution that we put in place when we're rushing. When I just spinning up a little Windows VM, I put Nagios, and I just do a couple of pinging. It's okay. It's a start, and it's better than nothing, of course. But in a cloud-native type of architecture, there we're looking at really architecting something that it's resilient, robust, and can really give us a lot more intelligence and information. And so we have a series of sensors, of course, that are going to read, from the hardware level, as we said, the different stages of what we're actually going to control and check, CPUs, etc. And then typically we put everything into aggregators. And then we've got different staging environment, if you like, in terms of the state engine, the storage engine, with time series type of databases. Of course, you can use cache. And when I look at these sensors here on the left-hand side, the sensors idea, it reminds me that in Sysmon MGR, in cache, we actually have the same architecture. So you can create your own sensors for your application. You can monitor exactly what you want. So the Sysmon MGR starts up automatically cache, and we have some standard default value for CPU and IOPS, but you can create your own sensors, and it's very, very easy. And then you can say, okay, if this sensor has this type of value, then you can send an alert or a warning, etc. So just remember that as well. We'll mention that later on again. So this is a composable, growing architecture that would allow me to really create a real, monitoring of my application. Like we said at the beginning, is not just the threats; it's more like the trending of my system. Is really understanding every element of everything I'm doing. And the idea here is that really it is an architecture. So again, as I develop so much care in my application, we should dedicate as much care to the monitoring system. Exactly because I don't have one single point of investigation, one single monitor, one single monolith, but I'm going to have thousands out there. So I'm just going to list some tools that are available out there. Okay, so it's commercial tools, and of course I'm not quoting all the specific IBM and HP or the big guys out there that obviously have a whole suite of information systems and monitoring systems. Some interesting one, New Relic, Dynatrace, Rocana, that says we've got specific algorithm for time series streams. So they say, well, I know if you got this type of time series coming from Nginx, and I know the type of error that Nginx can write to the log file. So they're really specializing on logs and how frequent this can come up, and they're really specializing on particular vertical, if you like, of the monitoring part. Very powerful, very nice. Probably very expensive. It's commercial. I don't know. The UI are fantastic of some of these tools. That's very nice. Then you notice some of the description I put there, like Sumo Logic, the machine data analytics, or on the right-hand side, Datadog. Everything is just like about this is data. Doesn't matter what it is. Doesn't have to be transaction or healthcare related. This is data that I'm getting. And so the next step is, I want to really understand what's going on in terms of trends, in terms of patterns of work, etc. So there, some of these companies really specialize in the analytics of these numbers that come through, and what does it mean? And then they compare these analytics with some other engine that they store, because some of these are just software as a service type of services out there. So you can send your information from your cloud or from your private cloud up there, and they analyze. So they got database, they keep collecting information, and so it becomes a real analytic backup information, feedback information that you get. This is very interesting. So big data is not just collecting lots of our customer data information. It's everything. And so remember the IoT session that we've had here at the developer conference at GS. Everything is important. Everything gives us some insight. We are changing, by changing the quantity, we change the essence, and now we understand the data and what it means for us. Lastly on this slide, the last few, you see that log entry, logly, logscape, that just completely focus only on logs analysis. So they don't care about the CPU and the RAM, just logs. and they make their life very easy. They already know, the standard, Nginx or Java logs, what they look like, etc., etc. So it's very easy to get started with. On the open source side, there are very interesting tools here. Some are, like on the right-hand side, where I say core, it means that there's a base level that you can get for free, and they also have a commercial offering, so that could be interesting too. Why is it interesting? Well, because as I said, it's not just about spinning up a little Windows VM with Nagios in there. It's about really creating an architecture, so and a real solution that looks after me really in the long term. And therefore, it might be good to start, with a core level. But at one stage, I might say, no, this is very important for me, and I'm prepared to put some dollars on the table for this because I have extra value, of course. But anyway, so we start on the left-hand side here with Nagios. The Insinga one that was based on the Nagios, but with version 2 is completely reviewed, especially in the UI side, quite interesting. Cacti, an old favorite of many sysadmin. New one, a couple of new ones here. The Prometheus project is really coming along very well, based on Go, and it's got slightly different architecture from the typical pool architecture that you see in another solution. Zabbix is another one that is becoming very famous, got very interesting, nice UI, just reviewed last month. They released a new version. And even here you have tools that allows you to just focus completely on logs file, for example, if you wanted to. I think I put them on the right-hand side somewhere. Yeah, an interesting one on the right-hand side is ELK, the Elasticsearch log stash. So the log stash that again analyze logs, and then it doesn't come bundled, but you can download Kibana as well, and that offers you a really nice UI to customize. Is there any other tool that maybe you're using that I haven't put there? There were a couple of comments yesterday on the same session. Open? Yeah, Open NMS. Yes, I saw that. One slide is not enough, to be honest. There's a lot out there. Yeah, but it's a good one too. Yeah, thank you. Couple of comments on the top right-hand side there. Collect it and start it. They're great at just collecting information and then push them off to tools like Graphite or ELK. So they don't offer full monitor solution, but they're just daemons, processes that just do one job, but they do it well. So again, following the Linux philosophy, that can be interesting. So you provision them inside my containers or my VMs, and then I get a centralized point where I collect, analyze my data, and where my architecture starts for the monitoring. So InterSystems has quite a few tools that you can use for monitoring, analyzing, doing post-mortem as well. The one that I mentioned is the last one down here, the Sysmon MGR. That is the all-encompassing utility, the one that you can really utilize yourself. You just subclass from a couple of superclasses, create your own sensor for your application. Very interesting, very easy to do. There is some example code from Global Summit 2 years ago that we're going to open source. But in general, if you just want to run statistics, there's several tools that are put there. But one thing that I would like to encourage you to do is, if you haven't done it already, to sign up to our developer community, where we already have some very interesting and in-depth article on how to switch on monitoring 24/7 on your system without ruining too much of your performance. I actually quite like some of those tools. And now you can help us when we need to help you, WRC, following you up, or even yourself, try to understand the pattern of work of your system. So I encourage you to really go to the community and search for these articles. So the tool that we presented a couple of years ago was a proof of concept. We called it S.A.M, System Alerting and Monitoring. It was more of thinking of a NOC type of operation, a data center where you got this big screen that you look at. which could be interesting, but people are not there staring at the screen all the time, and that's why we need to have alerting and trending and understand a little bit more about what it really means to have baseline and how the system is moving. And so S.A.M is composed of is made up of two components. One is a package that you can put into your %sys namespace in your application, and then there's just an appliance that has the collector, if you like, and in there things get analyzed, and if you have trouble, we show you with a red and yellow warning and what's happening on the system. The architecture is very simple, so you could use it yourself. We basically make use of our own system monitoring, and you can just put your code inside the sensors. The sensors then the information gets sent into S.A.M, which is this extra appliance that you set up, and then through WebSocket, we just drive up the UI so that you can see if any of your system has any problem. And as you've been so kind to come to this presentation, you are the first to know that we're going to open sources probably next week, and you can then ask for pull requests. There's a lot of improvement that obviously needs to be happening there, and a lot of development in all kind of direction that can be happening from there. And a couple of screens here to give you an idea what it looks like, so you can click on any of those nodes that have problems, and you can drill down and see what really is happening, what that sensor was detecting that maybe wasn't going very well. In summary, just 3 main points. Monitor is fundamental, especially in the cloud era and a big data type of infrastructure where you're going to have thousands of nodes. So that's our approach. Monitoring, as we said, is also a project that needs to be scoped, which means there's going to be resources, there's going to be cost associated with it, and it needs to be scoped because it's an architecture, really. And it's going to become more and more important. The more nodes, the more cloud application I have out there, and therefore it's becoming critical, because I really want to know, I really want to be paged, I really want to understand what a quote-unquote good system is, my baseline, and therefore be able to forecast where I'm going with my system in terms of resource usage and everything else. There are many good products out there, of course, and so you can pick from open source, core-based product, and commercial. But remember, back to point 2, fundamentally, it is a project that we need to really step back, have a look, design, implement, and make sure it's actually a system that has HA built in if we've got thousands of nodes. So with this, apparently I'm supposed to give a demo, but when I tried a few minutes ago before the presentation, the connection wasn't working because I'm connecting to AWS. It's only here in California, but it wasn't moving fast. So let's try again. If you can connect. It doesn't like it. Oh, the server's gone down. So I wanted to show you what it looks like, for example, in Ireland, which is usually the AWS region where I work on. Okay, so I've got like 400 nodes here. So somebody tells me, well, and that's already a lot of information. If you have a problem on your 333rd node, okay, so I'm here. This is my wonderful UI from AWS. So 1, 2, 3. Okay, 33, go down, pick it up, have a look at the information, maybe do a little bit of the monitoring, automatic monitoring that they offer you, and then what? Okay, so what I'm saying is it's just not doable to have a cloud architecture out there with thousands of nodes and expect people to go on a portal and click through lists of nodes and pages trying to find things out. We must set up an architecture for monitoring. It's a necessary evil, but I think at the end of the day, it's going to really, help us out in the long run, especially as far as capacity planning. And okay, yes, we can be elastic, and that's important. But at the same time, well, I would like to know, for example, when you spin up another 50 nodes for me, right? So there's all kind of consideration when we go into the cloud. And I hope the basic point of the presentation is that we need to really consider this as an important part of our application. You know, monitoring is part of it. It's very important. And with this, I'm basically finished, so we can all go to lunch early. Any question? Any experience that you might have had so far? Okay, well, thank you very much for your time. I will invite you again to join the community at InterSystems.com, where many interesting discussions take place. You can ask us questions, you can comment on presentation, really anything. We're there to help. Thank you very much, guys.